So we're up to the final lesson of Chapter 6, and that's all about graphing linear inequalities in two variables, which means we're going to have a y and an x, because we're going to use that coordinate plane. Now the first thing we're going to do is we're going to learn how to test whether an ordered pair is a solution to a given inequality. And all we're going to do for that is we're just going to go ahead and plug in the values here and see if it's a true statement. So in this case here, this here is the point I'm going to plug into this inequality and see if it's true. So it will be 0, where the x goes, plus 2 times 5 is less than 4. And then that's going to end up being 10 is less than 4. So the answer to this is going to be no, it's not a solution because 10 is not less than 4. So let's try this next one here. 2x plus 3y is greater than or equal to 14. We're going to plug in this, and we're going to see if it's a solution. For the x, we're going to go and do 2 times 5 plus 3 times 2 is greater than or equal to 14. And this is just like testing points on a line, except for there's a lot more solutions because there's all the shaded area, which we'll get to in a minute. So this is going to be 10 plus 6 is greater than 14. And so 16 is greater than or equal to 14. So yes, that's a yes there. Same thing here, we're just going to plug in the values. Y is less than or equal to 8. So all we're going to do is we're just going to plug in this because that's the only place I can plug in anything because that's where the y is. There's no x involved. So is 7 less than or equal to 8? Yes, it is. So that is a solution. For this one here, we've got 3x is greater than or equal to 15. There I just care about the x, not the y, because there's no y involved. So is 3 times 5 greater than or equal to 15? Is 15 greater than or equal to 15? Yes, it is. So one more time we have a yes there. So when solving for a linear inequality by graphing, what you're going to do is you're going to look at the inequality. You're going to graph the line that's represented by the inequality as if it was a line, and then you're going to shade in half of the graph. So let's look and see what that process looks like. So if this is my linear inequality, y is greater than 2x minus 1. First of all, I'm going to graph this line. Y is equal to 2x minus 1. So now what I'm going to do is I'm going to graph this like we've done dozens of times before. When x is 0, y is negative 1. When x is 1, y is going to be 1 also. When x is 2, y is going to be 3. I know that because I'm on slope intercept and I go up 2 every time I go over 1. Or you can just plug it in and see. So there are my 3 points. And now what I've got to do is I've got to connect those dots. But I've got to pay attention back up to here to now the inequality part. Since it says y is greater than, not greater than or equal to, it's going to be a dashed line because the line is not a solution. And I'll show you how that looks. So that's how that's going to look. And now I have to figure out which side is the side that has the solution on it. And the easiest way of doing that is by plugging in a point on one side of the inequality. And the point I always choose to plug in is going to be 0, 0. That's going to always work unless your line goes through 0, 0. So when I plug that in, I'm going to just plug it back into this inequality here. So 0 is greater than 2 times 0 minus 1. Is that a true statement? 0 is greater than negative 1. Yes, it is. So that means everything on the left-hand side, because that's the side that includes 0, 0, is a solution to the inequality. That means everything on this side is a solution. But not the line, because it's dashed. That's sort of like the filled-in versus non-filled-in circle part. So here's another linear inequality. 2x plus 3y is greater than 6. Again, first step, write it as an equation. Second step, solve the equation however you can. And I'm going to come up using intercepts. So when x is 0 and when y is 0. So when x is 0, y is 2. When y is 0, x is 3. So now I've got to go back up there and look and see, is it a filled in line or a non-filled in line? Since it has that doesn't say greater than or equal to, that means it's a non-filled in line. So that's how this is going to look. And the last step is testing out a point that's on one side of the line. As I said before, I always like to choose 0, 0 if I can, if the line doesn't go through it. The line does go through it, you just choose another point and test it. So here that's going to be 2 times 0 plus 3 times 0 is greater than 6, so that's going to be 0 is greater than 6. So that means everything on the 0, 0 side is not a solution, so that means everything on the other side is a solution. So now we have a new problem. Y is greater than or equal to 3. And there's no x here, so x doesn't matter. This is just the line that we would use would be y is equal to 3 to graph this. And so let's write that out. Well, we can just go ahead and do the line straight across, or we can do when x is 0, y is 3, when x is 1, y is 3, when x is 2, y is 3, and so on. And if you look closely, you can see those dots. However, since this is one of those ones where it says greater than or equal to, that means it's a straight line across, going through those points, and that means that that's a solution as well. I still have to test the other half and see which one is a solution. So here, I'm going to plug in 0, 0 into the equation, the inequality, excuse me. So it's going to be, well, I don't have a y, so is 0 greater than or equal to 3? No, it's not. So this stuff 0, 0 is not a solution. So everything on the other side is a solution. So that's how these work. It just is really all about graphing the line, seeing whether it's a dashed or dotted line, and then shading in the half that is the solution.